Hello students, welcome back. Today we will continue with the textual exercise of chapter number 3, motion in a straight line. Right? In our last video lecture we had completed question number 1, 2, 3 and 5. Okay, so today we will continue with the part 2 of textual exercise. Okay, so let's begin. Okay, question number 3.4. A drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward. Again by 5 steps forward and 3 steps backward and so on. Each step is 1 meter and require 1 second. Okay, so here I can write it down. 1 step equal to 1 meter and takes 1 second. Here, so now plot a graph of x to t of his motion. Okay, so let me draw a graph. Okay, y axis I will take it as x means position. Okay, x axis I will take it as t, that is time. Okay, now see the question is graphically how much time it will take for drunkards to fall in the pit. There was a pit at 13-meter away. Okay, so I need to make a length of the 13. So I write down 1 2 3 4 5 6 7 8 9 10 11 12 13. Okay, I have written the scale on y-axis. Okay, now say it's 5 step forward. So what I will do, I will make a gap of 5, 5, 5, 10, 15, 20, 20. Okay, let me have a wider space. 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay, so now I'm again drawing the graph. Okay, see, 5 steps, 5 seconds. Clear? So 1, 2, 3, 4, 5 here and 5 seconds. Right? So 5 seconds, 5 steps or 5 meter. Clear? See, x coordinate is the time, y coordinate is the position. Then 3 step backwards. So 3 seconds. 5 minus 3, that will be equal to 2. And time it will never go backward, so 5 plus 3 8, so between 5 and 8, 5 and 10, sorry, this will be 2, sorry, 8 and 2, right? This was the first jump, falling back, not falling back, moving back. Again 5, so 5 plus 2, it's 7, and 8, 8 plus 5. That means 8 plus 5, 13. It will be near between 10 and 15. So let's say here it's 13, and 2 plus 5, that is 7. It will be here, somewhere here. Okay, there may be some ups and downs. Okay, next. 3 steps backward, 3 seconds. So 13 plus 3 is 16. It will be here, approximately. And sorry, yes, 30 plus 16. And 3 step backward. And what was this position? This was position was 13, 7. So 13 plus 3 is 16. And 7 minus 3, that will be equal to 4. So it will be somewhere. Okay, so this is 16, and 7 minus 3, that will be equal to 4. So you can do it here in rough, like 5, 5. Every time add these 3, 5 plus 3, 8. Okay, and 5 minus 3, 2. Now plus 5. So 8 plus 5, 13, 2 plus 5, 7. Now plus 3, 13 plus 3, 16, 16 plus 5, 21, 21 plus 3, 25, sorry, 24, 24 plus 5, 29, okay, 29, sorry, 4 plus 5, plus 3, 32, 32 plus 5, 37. See what I'm doing? Time I am adding plus 3 plus 5 plus 3 plus 5 plus 3 plus 5. Okay, now this position 2 plus 5 minus 3 plus 5 minus 3 plus 5 minus 3. So 7 plus sorry 7 minus 3 4, 4 plus 5 9, 9 minus 3 6, 6 plus 5 11, 11 minus 3 8, 8 plus 5 13. So I got the position 13. I had solved this in rough. Now I can match it. Okay, so 16 4, after 16 4 it's 21 9. So 21 here and 9, so it will be somewhere here. 21 9. After that 24 6. So 24 it will be approximately here and 6. So this is 24 6. After that 29 11. So 29 it will be here and 11 somewhat here. So this 29 11. After that 32 8. 32 it will be approximately here and 8 here. This was 32 8. Then 30, sorry, 37 it will be. 32 plus 5, 37. Okay, so 37 it will be somewhere here and 13 will be here. Let's take 37, 13. So 37 second, 13 meter. Okay, so it will take 37 seconds for the drunkard to fall in a pit 13-meter away. Clear, students? So this was about 3.4. Note it down. Now let's move to the next 3.6. 3.5 we had already completed in our last video lecture. So now let's move to 3.6. 3.6. A car moving along a straight highway with a speed of 126 km per hour. Okay, means a car is moving this direction. Let's say the velocity is 126 kilometer per hour. Okay, is brought to a stop with a distance of 200 meter. Means if this is the starting point, okay, let's say after this distance A B, okay, here car stops. This distance D is equal to 200 meter. Okay, here car stops, so the final velocity, if I take this as V0 126, as it stops, this will be equal to 0 kilometer per hour or meter per second. I can directly write down. Now see the distance is given in meter, so I need to convert it into meter per second. So what I will do, shortcut for to convert kilometer per hour into meter per second into 5 by 18 meter per second. Okay, so I will multiply it directly. 126 multiply by 5 divide by 80. It's 35. Okay, so this will be equal to 35 meter per second. Clear? Now, what is the retardation? Okay, you can either use the formula like v square upon 2a, right? Breaking distance, you had already studied this formula. D equal to v0 square upon 2a. Here, okay, or else you can also use the formula like v square minus v0 square equal to 2ad. What is the final velocity? 0 minus initial velocity 35 square equal to 2 into a into what is the distance? 200. Clear? So a is equal to minus into 35 square upon 400. Okay, so let me calculate it. Okay, it's 35 into 35, okay, divided by 400. This is equal to 3.065. So round figure, I will take it as 3 meter per second square. Sorry, minus 3 meter per second square. Okay, this will be equal to minus 3 meter per second square. Okay, this is acceleration. So acceleration is there, so it's negative because it is decreasing. So retardation is equal to 3 meter per second square, right? See, remember, when I'm writing retardation, I will not use negative sign. Here, because when I'm using acceleration, I'm using negative sign. That means it is decreasing. That means retardation is 3 meter per second. Okay. Now, the second, how long does it take for the car to stop? How long does it take for the car to stop? Okay, so we require to find out the time. Okay, there are three kinematic equation v equal to v0 plus at. Okay, let's check first. Are we having final velocity? Yes. Are we having initial velocity? Yes. Are we having acceleration? Yes. Okay, so we will use v equal to v0 plus at. Final velocity 0, initial velocity 35 plus acceleration minus 3t. So minus 3t when it goes this side plus 3t equal to 35. T is equal to 35 by 3. Okay, that will be equal to 11.66 seconds. Okay, so it will take 11.66 second to stop. Okay, so this was about the second part. Okay, so 11.66 is the approximate answer because we have taken here round figure, right? Because here the answer was approximately near to, answer was 3.0625. So we have taken the round figure, right? So if you take here 3.0625, that will be near to 11.4. Clear? So now note down question number 3.6. Now let's move to the next question, that is 3.7. 3.7. Two trains A and B of length 400 meter each are moving on two parallel tracks with a uniform speed of 72 kilometer per hour in the same direction with A ahead of B. So see what I can tell. Let's take this as train A. Okay, this is train A. Okay, and both are in the same direction. So let's write down this as train B. Okay, here this is the distance between these two trees x. Okay. Now the driver of B decides to overtake A and accelerates by 1 meter per second. So what will be the see first velocity is given 72 kilometer per hour means velocity of A 72 kilometer per hour. Velocity of B 72 kilometer per hour. Now see A is not doing any acceleration. Only B is accelerating. So what I will do, I will take relative velocity. See this is moving with 72 kilometer per hour. This is moving with 72 kilometer per hour. So what is the relative velocity? 0. 72 minus 72. Just imagine that a student is going with 5 meter per second and second student is also going with 5 meter per second. Okay, then the distance between both these students will always remain same. That means the relative velocity of B with respect to A, that is equal to 72 minus 72, 0 kilometer per hour. Or I can also write down 0 meter per second, right? Whichever I will require, I can use. Both is 0. Now, the driver of B decides to overtake A by acceleration. So, what is acceleration of train B? That is given 1 meter per second. If after 50 seconds the guard of B, okay, guard of B means at this position. Here there will be the guard at the end of the train, right? Just brushes past the driver A. Now driver will be here, right? Here will be the driver. So after 50 seconds, this guard is brushing past. Means the train B has completely overtaken train A. Okay, and what was the time for that? T is equal to 50 seconds. What was the original distance between them? So this distance x, we need to find out this original distance x. Okay, so now what is the formula? We can use the kinematic equation like x equal to v0t plus half at square. So what is v0? Vb with respect to a t half ab t square. So 0 into time, that is 50 plus half. What is the acceleration? 1 and t square 50 square. So this will be equal to 0 plus 50 square, that is equal to 2500. So x is equal to 1250. Clear? So distance between two trains is 1250 meter. Okay, because the acceleration is in meter. So my answer is in meter. Okay, just this was about 3.7. Now let's move to the next, that is 3.8. Question number 3.8. On a two-lane road, car A is traveling with a speed of 36 kilometer per hour. Okay, two cars B and C approach car A in opposite direction with a speed of 54 kilometer per hour. Okay. So now everyone know what is a two-lane road. Okay. Now see car A. car A, let's say here is car A. Okay, let's take here it is car A. Okay, what is the speed of car A? V of A 36 kilometer per hour. So 36 into 5 by 18. That will be equal to 18 ones are 18 twos are. So that will be equal to 10 meter per second. Okay, moving in. Let's say it is moving in this direction. Okay. Now two cars B and C approaches car A in opposite direction. Okay, means B is coming in this way and C is coming in this way. Okay, so let's take car B approaching in this way and car C in this way. Okay, clear? So see, both are in opposite direction. B and C opposite direction. Approach is towards A. B is going toward A. C is going toward A. Okay, and both is having speed of 54 kilometer per hour. Right? So I will write down directly shortcut 54 into 5 by 18. Right? So 18 ones are 18 threes are. This will be equal to 15 meter per second. So what I will write down? Velocity of B 15 meter per second, velocity of C 15 meter per second. Clear? Now both of them decide to overtake. Now see, A decides to sorry B decides to overtake A before C. Right? So what must be the minimum acceleration of car B required to avoid an accident? Means car C is not doing any acceleration, only car B is doing. Clear? So it must be that when this car C approaches A, before that B must overtake. Okay? See, I am writing this way. When car C approaches towards A, before that B must overtake A. Clear? So what I need to find out? First, I will find out how much time C will take to approach A. But now I require relative velocity. Okay, this distance, this is PB 15. So what is relative velocity? I will take relative velocity of B with respect to A. Now see, both are moving in same direction. Now remember one shortcut. Okay, okay, when you are taking one dimension, if you don't want to take vector form, okay, then when two vehicles are moving in same direction, the relative speed you have to subtract, and when two vehicles are moving in opposite direction, for relative speed you have to add. So relative speed of B with respect to A is 15 and 10. So as it is in same direction, 15 minus 10, this will be equal to 5 meter per second. Relative speed of C with respect to A. Okay, so now see C with respect to A. So both are in opposite direction. So you have to add it. 15 plus 10, that will be equal to 25 meter per second. Okay. Now let's check how much time we have. Okay, how much time B will be having? It will, the maximum time will be that C will require to approach A. C will require to meet A. Okay, so this velocity is constant 25. Okay, this velocity is constant. Now see, the distance is 1 kilometer. That means this distance 1000 meter. 1 kilometer I convert it into meter. This distance also 1000 meter. Okay, so see what I am doing. This velocity equal to distance by time, right? Velocity v of ca, okay, or it is moving with velocity v, okay, and the distance is 1000. Velocity distance by time, time is equal to the distance by velocity. So time taken by c to reach a, what is the distance? 1000. And what is the velocity of ca? 25. Okay, so this will be equal to 40 seconds. Okay, time taken by C to reach A is 40 seconds. So 40 seconds is the maximum time that B is having to overtake. If it takes more than 40, it will collide with C. Okay, so now here the time is 40 seconds. Okay, I will take time equal to 40 seconds. The time it will have, it is having t equal to 40 seconds. I will take this 40 seconds here. Okay, I can use the formula x equal to v0 means v0 t vbat plus half a b t square. Clear? Okay, I am writing down this equation on here. Repeating x equal to vbat plus half EBT square. What is x? 1000 meter. What is VBA? 5. What is the time? 40 plus half. What is the acceleration that we need to find it out? What is t square? 40 square. Okay, so 40 into 5, that is 200. So 1000 minus 200 equal to half AB. 40 square means 1600. So AB will be equal to 1000 minus 200, 800 into this 2 will be multiplied to 1600 divided by. So 802, that is 1600, that is equal to 1 meter per second square. Clear? So what is the time required? Okay, or what is the acceleration, minimum acceleration? That means minimum acceleration of car B is 1 meter per second square to avoid an accident. Okay, so this was about 3.8. Okay, see what I did, I found out relative velocity of B with respect to A and C with respect to A. Okay, now to avoid accident, first I found out how much time C will take to reach A. Okay, it takes 40 seconds. So minimum time that B is having is 40 seconds. Within this 40 seconds, B must overtake. So T is 40 seconds, and I use the kinematic equation x equal to VBT plus half ABT square. Okay, actually this is the initial velocity of B with respect to A. So putting that value, I got acceleration 1 meter per second. So that is the minimum acceleration car B must require to avoid an accident. If it is more than 1, accident will be easily avoided. If it is less than 1, there will be an accident. So minimum acceleration is 1 meter per second square. Okay, so just note it down. Okay, students, so that's it for today. Today we had solved question number 3.4, 3.6, 3.7, and 3.8. Clear? We stop here. In our next video lecture, we will continue from question number 3.9. Okay, so that's it for today. Thank you.